Okay, so today we're going to be going over the derivative of the exponential function. And generally the exponential function is very easy to take the derivative of. Like e to the x is the same as its derivative; it stays the same, e to the x. But sometimes it gets a little complicated because of the chain rule, and there's multiple layers to these problems. So even this one here, e to the 1 over x isn't super easy to see at first. So we're gonna take the derivative of this. We're gonna go dy dx, dy dx, and then so e stays the same. So e1 to the x, and then now we're gonna do the chain rule of 1 over x. And so this isn't really easy to do in your head. So we'll go off to the side. 1 to the x. Well, we can rewrite that as x to the negative 1, and then now you just do the power rule. You multiply x by negative 1, and then you subtract 1 from the exponent. So then you get negative 1 times x to the negative second power, and then you can just rewrite it as negative 1 over x squared. And so now we're going to put that here. And negative 1 over x squared. And that will give us our final answer, dy dx is equal to negative e to the 1 over x over x squared. And that's our answer. Alright, next problem. So this one starts getting a little complicated. Usually if you're going to have an e to the x problem on like a test, they're not going to make it super easy and straightforward. It's going to be something a little bit more like this, something kind of messy. So we're going to start by taking our derivative, dy dx. So this is the chain rule with 3 functions. That means we're going to be taking 3 derivatives. So first we need to do the derivative of natural log, and derivative of natural log is just 1 over whatever is inside the natural log. So I'm going to underline this in green, or the natural log in green, and that's going to give us 1 over cosine e to the x. That's the derivative of natural log. You know what, I'm going to erase this, and then we're just going to underline just the natural log in green, because that's the derivative of natural log. And since it's a chain rule, we multiply by the next function inside. That's going to be cosine. So we'll underline that in blue. Derivative of cosine is going to be negative sine, and then whatever is inside the function stays the same, e to the x. And we can go ahead and underline this in blue, because that's the derivative of cosine. Underline this in green, because that's the derivative of natural log. And lastly, now we need the derivative of the function inside cosine. We'll underline in this orange color here. That's going to be derivative of e to the x, and that should be the easiest part of this problem. Derivative of e to the x is just e to the x. Then we'll underline that also. Okay, so at this point now we have our 3 derivatives, and now we just multiply them together to get a final answer. But we can simplify, and we can see that we have a sine ex over cosine ex. And since the arguments are the same of cosine and sine, they both have e to the x inside, we can turn this into a tangent. So our final answer is going to be dy dx equal to, remember there's a negative e to the x times tangent e to the x. And that's our final answer. This x was a little messy. I'll go ahead and rewrite it. This is tangent e to the x. Okay, next problem. So now we have just a regular e, but then we have something a little bit messy in the exponent. So instead of e to the x, we have this messy problem here. But we're going to approach it the same way as a chain rule problem, because it is a function inside of a function. Okay, so derivative of e stays the same. Doesn't matter what it is stays the same, as long as it's e. But now, since there's a function inside of a function, we need to take a second derivative here. So that's cubed. Now we need to multiply the derivative of this inside part. So I'm going to underline this in blue and underline the e here. The derivative of e is right here. Now I'll underline the square root in green. And so the square root in green, we're going to do it off to the side because it is a little bit messy. So we can rewrite the square root as 1 plus 5x cubed to the 1/2. And then we just use our power rule. So multiply by 1/2, 1 plus 5x cubed, and then negative 1/2 in the exponent now, because we subtracted 1 from 1/2. 1/2 minus 1 is negative 1/2. So that's the derivative of this here. And then I'll go ahead and rewrite this 5 here. 5, okay. So this is the second part of the derivative here. 1/2, 1 plus 5x cubed. And that's also the negative 1/2. And now we still need one more derivative because there's another function inside of the function. We have a 5x cubed inside that square root. We'll underline that in orange. And so now we just multiply this by the derivative of what's inside the function, which is actually, it's also 1 plus 5 to the x cubed. Okay, so the derivative of 1 is 0. Derivative of 5x cubed is going to be, using the power rule, we'll get 15x squared. Okay, and so underline this in green to show that this is from the, oh, that's not green, it's black. Underline this in green to show that that's the derivative of the square root, and then underline this last part to show that it's the derivative of the function inside of the square root. And so now we're actually done taking derivatives. Now we can just simplify it. So now we're gonna rewrite everything, see if anything can be simplified. So can anything be simplified? We have an e2 exponent here, we have a square root here, and then we have just a number with an x squared. So it doesn't look like anything is going to be able to simplify, but we can rewrite it so that it's a little bit nicer. So we'll have 15x squared times e to the 1 plus 5x cubed. That's going to be over 2. This 2 comes from the 1/2. And then since this is a negative exponent up here, negative 1/2, we're just going to rewrite it as a square root in the denominator. So 2 times the square root of 1 plus 5x cubed. Alright, and that's our final answer.